Well, thanks for coming, everyone. Hope everyone had a great lunch and hope everyone's not too much in a food coma right now. We'll try to not bore you. We'll try to not make you fall asleep. But if you feel like you need to shut your eyes, feel free. Well, thanks for coming. My name is Tasha. I have a cat. That is my whole personality. And I work at Tinder with Akshay. Do you want to read? Okay.
Thanks, Tasha. Hi, I'm Akshay Chordiya. I'm a Google developer expert for Android and Kotlin. I love national parks. That's why the emoji. And I work at Tinder with Tasha here.
Thank you. All right. So what is this talk about and why are we giving this talk? So at Tinder, we've been gradually introducing Compose into our app, one screen at a time. And let me tell you, it's been quite a journey, but that's for another talk. And we've had to deal with a lot of interop with Compose and Android views, and we've had our fair share of oops moments, including unintentionally building screens with a very good amount of UI jank. And the process of diagnosing and fixing performance issues, especially UI jank, can feel a lot like detective work, and can feel like you're thrown into a sea of red flags and you kind of swim your way to solutions. So this talk is going to be about us sharing that adventure with you guys. With a live debugging session lined up to hopefully arm you guys with some ideas to overcome your own UI jank challenges. And fingers crossed. Oh my God, fingers crossed. All right, so Akshay is going to talk next about what we're going to be fixing today.
Yeah, let me just scroll down here. So yeah, introducing the janky Tinder. So we, in order to explore these ideas further in a sandbox environment, we worked off a clone of Tinder app, built solely in Compose, but you can swipe on cats here. This allowed us to explore how jank could seep into your app as one kept building layers on top of it. So we added like 3 screens here. The first one is the card stack, where you can swipe on cats, like, dislike, probably you'll just always like them. Then we have the second screen, which is the match list, where you see all the matches and the chat with them. And lastly, there is the profile screen, where you just see the profile, your own profile. So our task, or actually our mission that we are forced to do, is to fix the janky card swipes. So what's wrong with this is like you see the dragging is super janky, the swiping is so laggy. And in a classic Jira fashion, we have the acceptance criteria, which is to make the card swipe super smooth and have a butter-like card drag. So with that in mind, let's jump to our first tool, which is the GPU rendering. So this is the same tool which we use right now in the Vue world, which still applies in the Compose world. So the green bar indicates the CPU operation happening on the UI thread, and there is a horizontal line which indicates the 16 millisecond mark. The red horizontal line. And we always want our bars to be below that, because anything above that line means there is a lag, and it's actually a user noticeable line, user noticeable jank. So this tool is like super helpful to know where the jank is coming from and how bad it is. Tasha is actually going to jump into the second tool and dive deeper into like where this issue is coming from.
All right, I think you got to hold on to this one because we use that mic.
Oh, you should.
Hello? Okay, this is working. Okay, so as Akshay mentioned, clearly there's something stupid going on with our CPU usage. So we're going to dive in and try to diagnose and see what's going on. So for that, we're going to turn to our trusty Android Studio profiler. So let me turn off the bars. We're going to head over and open the profiler. So this is what that looks like. You've probably seen this before. If you don't have it available here, you can access it via View, Tool, Windows, and then find it around here. So you've probably seen the profiler before many times. You've used it, maybe run some traces and things like that. So we're going to look at these 2 areas here in this window. So this is already not attached to the process, so we're going to do that. That's our process, and it's attaching. So while it's attaching, I don't know how small that is, but there's a little disclaimer here. Profiling with complete data does not represent app performance in production. So if you are doing this IRL in a real production app, to get the closest behavior to production app or really spoiled, you're going to want to come here and choose the lower head option. There will be a few things that you won't be able to see with the low overhead option. So here, for this talk, we're going to stick with the complete data. So the first thing we'll draw our eyes to is this scrolling area here, the CPU area. So this is going to show us our CPU usage over time as we interact with the app. So if I click into this, it's going to show me a window with more detail. And so if I interact with the app here, you can see that my interaction is recorded in this red area, and the CPU usage is kind of shown here. So far, so good. So you might have seen this already. So for diagnosing the CPU issues for this part of the app, we're going to dive into a couple of the tracing options we have here. So you might already know what a trace is. You know, you hit record, do stuff on your app, stop it, see what happened, try to figure out where your performance bottlenecks are. So the first kind of trace we're going to talk about is the method trace. So this is actually going to instrument the beginning and ending of each method call. So as you can imagine, it's a lot of overhead. So there's a little disclaimer here too. This incurs high overhead. In fact, you're going to hit file size limits if your part of the UI that you're interacting with is calling a lot of methods and you're running a method trace. So you're just not going to be able to see the trace at all. So we're not going to do that today, even though it would give us more insight into what methods are being called and what our performance bottlenecks are probably. The system trace, on the other hand, you might be familiar with it as the systrace profile that you can run from the terminal, et cetera. System trace is different. You're going to get fine-grained details about the app's interaction with system resources. But then you lose out on that extra detail of like, oh, what are my methods that are running here? What should I be really looking at? Where are the bottlenecks? You lose out on all of that, but there's very little overhead, and it's generally much quicker to run a systrace and parse the trace and read it. Now, for our purposes, we're interested in nailing down at the compose level to figure out what the composables are that we are calling that's causing these performance issues. So historically, system trace has been limited. It's pretty much only shows sort of one recompose block per frame. It kind of just tells you, well, just recomposed here, with no further information. But there is a new library called the composition tracing library, and it's in its alpha state. So we'll come to the build script. So here it is. And it's alpha 3 right now. There's an alpha 4. We tried that. There's a crash. Don't try it. So composition tracing. It kind of combines the low overhead of a system trace with the detail of a method trace. So you get the best of both worlds. So we're going to give that a shot and see what we see in the trace. So to do that, so we've built the app with this library already integrated. That's what's running on the device right now. We're using a Pixel 3a XL to get the most jank. So we're going to select system trace, hit record, and then I'm going to drag on the card stack. There we go. Okay, this is so bad. This is awful. Did you code this? All right, stop. Okay, so it's going to take a sec to parse. All right, so the interesting things here. Some of these windows are a little annoying, but to draw your eyes first to this area of janky frames, all these red squares are parts where our app missed the rendering deadline. So if we click on this here, we were supposed to have done something in 21 milliseconds, but it actually took more than 300. That's bad. So if you're seeing jank, quantitatively, like you're just using the app yourself and you're like, yeah, it's kind of janky, but I don't know, man, is it just me? Is it just my device or whatever? So if you run it with a profile and you see these janky frames, you can kind of bolster your hypothesis, like, yeah, there's some bad stuff happening on the screen. So another thing here is you can kind of drag and you can kind of like see different parts of the trace. The controls here can be a little janky, so be mindful of that. Your system trace will be saved. So you can come back to it. I think until you close the Android Studio, it should be saved. So our issue was on the card stack. This trace, the compose tracing library, will actually show us what the composables are that are causing the issue. So if we look here, we're going to see that there's something called as a swipeable card that's called. And you can see that's our package name. So there's clearly something bad going on here. So generally the width of these calls or these rectangles in the trace will indicate that that's probably a performance bottleneck. So something is happening when we drag. It's taking the card stack a long time to show up. the swipeable card, whatever that is, we'll see in a second, is also taking a long time. It's doing a lot of stuff. We have some keyboard controls we can use, and if we zoom out, we can see like there's a ton of stuff going on. God knows what that is. Akshay, help us out here.
Yeah, let me take over. So now that Tasha has like found that where the issue is coming from, so let's actually use, let me actually like stop this. Let's actually use Layout Inspector to know what the issue is. So let me just hold this here. We don't need the running device anymore. So you said swipeable card, right?
Yeah.
Swipeable card. So, oh, damn, this is the layout hierarchy, by the way. And you can see that there are like hundreds and thousands of cards actually allocated already. But like you're on this card stack, right? Like you might just swipe 2 or 3 cards. So you don't need like all of them rendered right away. So something clearly is going wrong here. And I think this is the right direction. So let's just, and the cool thing about Layout Inspector is like if you click here, it just takes you to the source code. So something clearly is wrong with the swipeable card. It seems like it's been like it's visible even though it shouldn't be, because we just want like a couple of cards to be visible, and as you swipe, they keep getting added. So we have this business logic function like is card visible. Let's check there. So this looks good because it's saying that like 3 cards at a time should be visible, like the top 3 cards on the stack, but the rest shouldn't be. So this is correct. Nothing wrong here. So let's see where this is used. So this value is actually passed to a modifier called as visible. So let's jump in there. And so there is a custom modifier. So we are using the layout modifier. And here we are doing a measure. And then when the item is visible, we are actually placing it. But the weird thing is, the measure is happening even though the card is not visible. That's wrong, right? So we should be actually like, if it's visible, doing the measure phase, because compose is doing the measuring phase, even though the card is not visible and we don't plan to show it. So now that we did this fix, let's run and see if that made any improvement.
That's kind of a silly mistake that should have been caught in code review.
I totally agree. So it's attaching. It takes a while sometimes, but it should be there. So we search again for swipeable card. And there are only 3 now.
Ooh, what did you do, Akshay?
Yeah, let me explain like what is happening here. So compose has 3 phases: composition, layout, and drawing. And layout is actually made up of 2 phases, like measure and place. So what's happening here is like in the first phase, composition, what compose does is like it takes your composable, it draws a wireframe or a description of what you want to do on the UI. And the next phase is measure, where the width and the height of your composable is actually calculated. And so what's happening with our previous code was that we were doing this measure even though it's not visible, like all those cards are not visible. So all the swipeable cards were getting like computed, like all their width and height was getting computed, even though we didn't plan to place them or like make them visible. So that's like extra overhead for compose. And in the place phase, what compose does is like whatever it has measured, it takes that and it places, it kind of like finds, places them on the X and Y coordinates of your screen. And then what was happening is like in the measure, now that we have moved it inside the, if it's visible or not, what's gonna happen is it's gonna just take the 3 cards which our business logic said. So it's only gonna measure those 3 cards because they are the only one visible, and then place them on the UI. And lastly, in the drawing phase, it actually draws that on the canvas. So let's see if there's more junk now that we've fixed it.
Yep.
So let's try scrolling. Oh wait, actually I need to connect the layout inspector.
Okay, so you just dragged that card. Let me do that again.
Mm-hmm.
And there's like that blue square over there. So if you close that.
Yeah.
Okay, so you close the running device. Okay, so if you can direct your eye to this blue stuff that's happening, I don't know what's going on there. There's a number that keeps going up. As I drag the card, that doesn't look good.
Yeah. So let me see like what that number is. So it looks like it's the number of times this composable has been recomposed. What's that?
Ah, the magic word.
Yeah.
Okay. Okay, are we ready?
Yep.
We're going to talk about everybody's favorite topic, recomposition. Okay.
Yay.
Okay, so this topic has been covered to death. So you've seen talks, you've seen articles, you've seen videos. You know it all. You know recomposition. You know it. We're just going to do a quick overview and the highlights. So as Akshay mentioned, there are three phases: composition, layout, and drawing. So recomposition is the idea that all these phases, or some of these phases, need to run again when something changes. And the cool thing about Compose is that it might or might not decide to run all three phases, depending on certain things. So let's say you start out with your UI, and Compose is supposed to show everything on screen. So you've run through all three phases. It's composed stuff, it's laid it out, and it's drawn stuff on screen. Now let's say that a change comes in where you're drawing a new rectangle with a new color. This is essentially just a drawing operation. You're not changing the UI tree, you're not moving things around, you're just changing the color of something. So in this case, Compose might see this and think, well, I don't actually need to run composition and layout, I can just rerun the drawing phase in the next frame. Now let's say that another thing happens. Let's say that a new text composable is added to your UI tree, and it's like depends on some type of Boolean. In this case, Compose might think, well, the UI tree has changed, so I pretty much have to do everything. I have to run all three phases, most likely. In this case, nothing skipped. Finally, let's say that there's another change where the offset of one of the composables has changed and it's been moved around. In this case, Compose might think, well, the UI tree hasn't changed. If you're using a lambda modifier, which we will talk about in a second. But Compose might think that, okay, the UI tree itself hasn't changed. It's just the position of maybe one of the composables that's changed, and it might think to itself, as the self-aware entity that it is, that it might need to skip the composition phase and just run the layout phase and probably also the drawing phase. So the idea here is that Compose is smart enough or is intelligent enough to decide this on its own. But if you do something funky in your app to confuse it to the amount where it thinks it needs to rerun every phase all the time, that's when jank seeps in, and that's when you'll start having performance issues. So let's try to fix these recompositions. And we'll go back to Android Studio. Okay, so the first thing we actually talked about, pointed out, was that this number over here is just racking up as we interact with the app. And in fact, the layout inspector isn't even able to render this in real time. So it actually takes a second to show up. So if I swipe these cards, another weird thing I'm seeing is this number, watch that go up as I swipe the cards away. So this composable, the gamepad overlay, is these three buttons at the bottom. Now the weird thing is I'm not touching these buttons, I'm not making any changes to these buttons. They shouldn't recompose. Nothing to do with these buttons is changing. Why are they recomposing? So let's double click from the layout inspector. It's cool that you can go directly to source from here. And let's see how it's being declared. So here we have the gamepad overlay composable being declared. It's in an if block, and it actually depends on this condition. So if the cards are empty, we don't want to show the gamepad. We don't want to show these buttons. Now, the weird thing is the cards are not getting empty. We're just removing one card at a time, and there's still cards there. So this shouldn't recompose, right, Akshay?
Yeah, I know, right? Like I spent like countless hours and like sleepless nights on this, and after reading a lot of articles, I stumbled upon the secret book of Compose Performance.
The what? The what?
The secret book of Compose Performance. And the first thing actually it said was to use derived state of to limit recompositions.
Use what?
Derived state of.
I have no idea what that is.
Let me explain. So it says that so right now we have this state of cards, and we are essentially checking if it's empty or not to show the gamepad overlay. So what's happening is like whenever the cards change, Compose thinks that the state has changed, and that's why it thinks that it needs to recompose. And that's what it's doing right now. So what we need to do is like wrap this in a derived state of block. And that will create a new state for compose called as, let's say, show gamepad. And it will rely on that. So what's going to happen is, like, whenever your cards are changed, this new derived state hasn't changed because it's still valid. The cards are not empty. And that's why compose will know that it doesn't need to recompose it again. And so, for instance, like it will only recompose when all the cards are gone, the derived state value has actually changed, and that's when it will recompose. And that's when we want it to actually recompose and change the gamepad overlay. So with that in mind, do you want to give it a shot, Tasha?
Yes. Let's see if the secret book tricks work.
It will.
All right. So we're going to go back, and this is the condition that we are worried about. So we will get rid of this and fill that up. And you said show gamepad. Is that what it's called?
Yep, that's correct.
All right.
With the derived state of.
Okay, cool. So we got that. It's the same condition as before. We'll take that and we'll put it in here. Why is it red? Well, derived state of is going to return a snapshot state. So we're going to have to get at it via the value. All right, so with this, let's run it and see if anything changes.
The funny story is that this actually uses a distinct until change to know if the derived state is actually changed or not.
All right, layout inspector is going there. We will search for the gamepad overlay. There it is. Okay, so I'm going to swipe, and it shouldn't recompose, right?
That's correct.
Okay.
Let's see if the magical book holds.
Oh my God, it's working. Oh my God, it's not recomposing.
Yay.
Yay. Oh, thank you. Don't thank us, thank the book. That's where it was. All right.
But wait, like I see, I mean, the gamepad is not recomposing, but the cards are still, and that's a lot.
This is pretty bad.
Yeah. Looks like the swipeable card is doing a lot.
Yep. Does the book say anything else?
Let me see. I think the book said one more thing. And it said to use lambda versions of modifiers for frequently changing data.
They have lambda versions of that?
Yeah.
Okay.
So let me explain. So we have this swipeable card which you have been seeing so far. It internally has a card, a material card. And we are setting some modifiers to it, like specifically the offset and graphics layer. So what's happening here is that whenever the values of this modifier is changing, like the X and Y for offset, or the scale for the graphics layer, Compose thinks that this has changed, and it feels that it needs to recompose the whole thing. And that's why the whole node, like the swipeable card, is recomposing.
Wait, hang on. Are you saying that modifiers are immutable, and if we change something here, it needs to like think the UI tree is changing?
That
so
is
modifier
correct.
Gets replaced with another one?
That is correct.
And we don't want that.
So the solution to that is to tell Compose that actually use lambda modifiers. That way, Compose can scope it down and just scope down the tree and just do it inside the modifier, and essentially like do it somewhere in like layout phase or something instead of recomposing the whole tree.
All right.
You want to try that, Tasha?
Yes. We will try the second tip.
Try all the magical things.
Oh my God. All right. So you said swipeable card?
That's correct.
Okay. So we're going swipeable card. Let's click into it. Okay, you're right. We are using the offset modifier and the graphics layer, and they're clearly not lambda versions. So let's start with the graphics layer one. So I think there's a lambda version of this, right? There it is.
Mm-hmm.
So maybe we could just move all these in here. Get rid of the commas. That's happy. We can get rid of this.
But could we eliminate the offset? Or is there a lambda version for that?
Oh, right. There is, but I don't want two modifiers.
Yeah, could we use one?
Okay.
It's nicer.
That's better. Let's see. So let's click on a graphics layer, receiver on, graphics layer scope. What do we have? Scale X, scale Y, alpha, translation X and Y. That's probably something we can use. So let's go back. And let's actually use that. Set up a template, so it's easier. So we're going to basically do the same thing over here, just with the graphics layer scope. So we can get rid of this completely. Yay, that's so much cleaner. Awesome. So let's run this and see what it does. Okay. And one interesting thing about the layout inspector, this little green button here is the live updates button, which we have enabled. So it will stream live updates from your app as you use it, which is super handy. So we have it loaded up. Let's go to swipeable card. Okay, moment of truth. So I should drag, and I shouldn't really see that number go up too much. Okay, so I'm gonna drag.
Just note that it takes a while sometimes for the layout inspector to actually pull those numbers.
Correct, and layout inspector has its own overhead. So don't use both layout inspector and profiler at the same time.
It's a bit better. I guess the book is working.
I don't know, man. This number is going up. What else does the book say?
Hang on. I think there was one more thing in the book. So there was a small section. Let me just pull that up. So it said like defer state reads as long as possible. So let's see what that means. So right now we have the swipeable card, and we are reading the state somewhere inside that parameter block. And so what's happening is, like, whenever you do a state read, Compose thinks that takes the nearest scope, and it feels that is its like recomposition scope. So whenever our state is changing, the swipeable card is getting invalidated because Compose thinks that's the recomposition scope. So we kind of like need to tell Compose, that's not my recomposition scope. Can you just shorten it down? And we can do that by deferring the state reads with the help of lambdas. And so here, these parameters which were passed from swipeable card are actually used in the graphics layer. So what we will do is we'll pass the lambda for the scale factor in there. So we'll do the state reading inside the graphics layer where it's actually needed. And that way, Compose will know that the scope is actually just that much and doesn't need to recompose the whole swipeable card. So Tasha, with that magical knowledge in mind, do you want to give it a try?
Yes, let's go back to your studio. Okay, so you're saying that swipeable card is called here, and it's reading a bunch of things and it's invalidating stuff around it. Okay, so the scale factor and the can start dragging, those are the two parameters you were talking about?
That's correct.
Okay, so this is reading something called item size, which is coming from state.cards. What is this? Okay, this is a snapshot state list. So if this changes, Compose is going to be notified. So it looks like we are reading something that's based on that here. I'm just reading it out in the open. We also do it here. And here, in fact, we read another state. We look at that too. It's also a snapshot state. So we're reading a bunch of state things right out in the open. So we're saying convert these to lambdas, right, Akshay?
That's correct.
Okay. Let's do it. So we'll do it here. And we'll do it for this one. And we'll surround with lambdas. We'll make this happy. All the way down. Okay, there's a custom modifier. What does this do? It doesn't matter. We just gotta work with it. Make that happy as well. Okay. This is green, that's green. Let's go back to the call site. This is not green. Fix that. Surround with this. All right. Okay, so all that might not be that obvious because you might not immediately notice this. So the lambda surrounding the state read means that the state is actually going to get read whenever the lambda gets called, which is way down here, and also way down here. So let's run this and see what we get. Okay, so hopefully a recomposition should go way, way down for swipeable card.
That's the magical book saying, not me, so don't blame me.
All right, if it doesn't work, it's not on you. You're right. Okay, moment of truth. We'll zoom in a little bit. All right, swiping, so I've taken the card out. Okay. Oh my God.
Is the magic working?
I think it's working. And I can also move this card around fairly easily. Like last time I couldn't even do anything with the card.
It's amazing.
Okay, so looks like that did the trick. It's not recomposing as much. You want to give it a shot?
Yeah. So actually, let me kill the layout inspector so I can get the real feel of the performance and pull up the running device here. Ooh, wow. That's so fluid. Wow.
That looks great.
Even the swipes are fluid. Thank you, guys. But yeah, let me try a few more things. I'm a QA. I'm a good QA.
Good. That's good.
Does the performance feel a bit janky when navigating between the pages?
I think so. It's like taking a while to settle or something. Okay. Layout inspector. Yeah,
let's go to our favorite layout inspector. Let's minimize the running device and just select.
Make sure your profiler isn't running.
That's a good point. And
okay,
it's not running.
So that red button or that stop button isn't on the left. Yep. Nice.
Okay, so coming back here, and I think this is the view pager which we are using, right? So let's search for pager. So we have this home pager. Let me just, and let's try navigating now. It's recomposing each time we are navigating to different page. See the count here?
That shouldn't be happening. I mean, we're not changing the pages. They're it's just static.
Let me jump to the code and see if there's something here. So this looks like it's just a standard pager. We have some tabs. And these pages, what are these? So this is a normal list of.
Yep, we're not changing it either. It's like a static thing. Okay.
Yeah, so it should be happening, right?
Is there anything about the book? In the book about this?
Yeah, I reached the end. Like, I mean, I don't see anything in the book, but
oh my God.
I did see a page missing in there.
A page missing?
Yeah.
Oh my God, wait a second.
Does anyone have that page?
No,
Tasha, you have been carrying it all the time.
Yup. Okay. So this was, I just found it on the floor. I don't know. Maybe you opened the book, it fell down. I don't know. Right?
Maybe it's an advanced spell.
Maybe it's so advanced you're not supposed to know about this.
Yeah.
Okay, so let's throw this up on the screen so everyone can see.
Yep.
Okay, oh my God. So this is pretty advanced stuff, guys. Okay, so no wonder this was torn up. This is only something you should do if you've no other options and you cannot figure out what's going on with your UI. Okay, compose compiler metrics. I like to think of this as basically a code review from the compiler telling you what it thinks about your code and going nuts about it. So it might say some nasty stuff about your code. You just got to be okay with it. It's wild that there was a Gradle command in this old book.
It's just an advanced spell.
Anyway, but okay. So a little bit about the compiler metrics. So they're not enabled by default, and you have to kind of add a compiler argument to turn them on. So we do that by specifying a destination for which it can use to put the compiler metrics and the reports in. And then we also have a build flag for us to be able to control that. We can generate these with the assemble task, and you want to pick the release variant because you want something that's as close to what your users see, and that also doesn't have any of the extra overhead that a debug variant would have. Thanks. And you also want to make sure to run rerun tasks. So if you're doing an incremental build or if caching and stuff that could get messed up, you want to make sure that the assemble task is run and any other tasks associated with it are also run. So we can set this up. We run this command. I think we already did that. Akshay, show us what we got.
Yeah, so what I did is I already run this command because I saw this advanced spell and I got so attracted. So you said it's generating output in some folder, right? I think it's build outputs. Looks like it's not here.
It's not there.
Maybe I think it got here. I think Git is thinking that it got deleted. That's fine. Okay, let's go to the composable.txt. So essentially, what this is doing is showing it's generating this text file of all the composables you have in the module. But we have the issue with the pager, right? So let's search for home pager. Oh yeah, I see it. Okay. So there are two parameters which are stable and one unstable. That's weird, right? List is supposed to be stable. It's not an immutable list. Or it's not a mutable list or something. List is immutable. Why is it unstable, Tasha? Why?
Oh my God. Okay, so the book did have that page had something to say about it on the other side of the page. Okay, so it says unstable. That obviously sounds like something negative. That may be something we should be concerned about. Maybe that's what's causing the recompositions. So let's go back here and see what that means. So essentially, what the unstable the compose compiler thinking that your parameter is unstable, what it effectively means is that if anything around this composable recomposes, compose will have to recompose this composable as well, and it cannot skip it. Because it can't guarantee that nothing changed. It will always assume that something changed to stay on the safe side. So for example, in this case, let's say we have a list of home pages, 1, 2, 3. Let's say we get a page change event, like change the page or something. This thing's going to recompose, increase recomposition count, even though nothing changed in the state. And if it happens again, it's going to keep going. So we're going to just keep racking up recompositions because it always thinks that this composable needs to run no matter what. So why does it think that? So in this particular scenario, the list of pages of the app, the list isn't going to change. We're not dynamically removing or adding anything. We're just creating it once and forgetting about it. So ideally, we want the compose to think that this parameter should be stable. We know it will never change. We need to convince the compiler that it will never change. But why does it think that a list is unstable? So a list is an interface, and it can be implemented in many different ways. One of those ways is to declare a mutable list. So you can be swapping things in and out of that list behind the scenes, and compose won't know about it. So it's errs safe side and considers unstable. So to fix this, you could use the Kotlin immutable collections immutable list. In this case, this is actually okay to use because we know that this list isn't changing. So don't use it if your list is actually going to change. And you can kind of create an immutable list via the persistent list of builder or builder similar to that. And note that from compose compiler version 1.4.0 and above, all the immutable collection types from that library are supported. I think prior to that, a couple of things weren't supported. So keep that in mind. So, Akshay, can we fix it?
Yep, let me try. Okay, so you said so the issue is from home page, right? So let's go there. And your suggestion from the page was to use immutable list here, right? Okay, let's go to the call side and see if everything's good. So home pages is a list. Let's go in here. And I think this needs to be persisted list, right? Because, yeah, the page. Okay, let's do that. In the interest of time, we have actually already run the compiler metric. So let me show how that looks like. So we go to the txt file, and we go to this home pager, and now it says stable.
Yay!
That's working.
All right, let's try it on the device.
Okay, let's try it on the device. So run it. It's going to take a sec. Let's close this. Expand the layout inspector. EDB attach. Okay, back to pager. So let's try navigating. Yay, the home pager is not recomposing anymore when you change the tabs.
What's that number though?
That's a good question. So that number, it says that number of times the recomposition has been skipped.
Oh wait, is that what it says on that text file? Skippable? Is that what that means?
Oh,
Nice.
Oh, I see it now. Okay, that's a good one.
So wait, if you open the old composables.txt, you wouldn't find that skippable?
Yep. Let me see. It's a good point. Oh yeah, it's not here.
Oh, nice. Okay, awesome. So it can skip it. We've convinced it.
Okay. Now that we've fixed this, let's actually get a full feel of how the app looks like. So the navigation is good. I think, did we kill all the tools? I think so, yeah. So the navigation is good. Swiping. Ooh, nice. So I think we did a good job here, and we can ship this. Let's mark our ticket as done. Damn it, my Jira isn't working, Tasha.
Always.
Can you update this ticket?
Oh my God, okay, fine. Here you go. Okay.
Thank you, Tasha.
So everything's off. Oop. Is everything off? No, it's not. Oh wait, layout inspector is still on. Okay, now we'll get the real deal. Yay!
Damn,
okay.
I missed the layout inspector. Sneaky.
I know. All right, so let's mark the ticket as done. This was our task. I think we achieved it. We are seeing some other recompositions and things that maybe are not supposed to be there, so we can take our time and iteratively build on this and fix it. So just to quickly cover what we talked about today. The first thing we did was we realized that we don't really need to render more than we need. So we kind of built a makeshift lazy box or lazy card stack, if you will. So in practice, if you are building parts of UIs that have a lot of off-screen children, obviously consider using the lazy variant of those composables or build a lazy variant of it yourself. Use derived state of. So if you have something, if you're state changing very frequently and you need to kind of change something else based on a subset of those changes, derived state of will come in handy. And if you have frequently changing states and you're kind of reading that frequently changing state way up in your UI hierarchy, you probably don't want to do that. You probably only want to read it where it's really necessary so that you don't invalidate more than is necessary. In a similar vein, also consider using the Lambda versions of modifiers for frequently changing data, frequently changing states, so that with similar reasoning, you are deferring those state reads further down and you're not actually affecting the composition. And then finally, if all else fails, you can't figure out what's going on, you can't figure out where your performance issues are coming from, run the compiler metrics to get some more information, and hopefully that should point you in the right direction.
Wait, most of the tips are coming from the book.
That's true. That's true.
The book was
I'm
useful.
so glad we found that book.
Yeah.
We wouldn't have been able to do this talk without it.
I agree, and also the page.
Oh, that page, exactly. All right. And finally, if you're doing this in practice, use release builds. We didn't do that here, obviously, in the interest of time. Use release builds because that gives you the closest to what the user sees in the wild. You don't have any of the debug overhead. You can add the profilable tag to your application to actually be able to use a release build and hook up the profiler, so that's awesome. And Akshay, could you wrap us up here?
Yep, so let me summarize. So use UI rendering bars and profiler to know where the issue is, and then use the layout inspector and the recomposition count to know what the issue is. And finally, if none of that works, use compiler metrics to know why in first place this is happening to you. And essentially, these are like the 3 pillars of finding jank or performance issues in Compose. At least that's what we found, or the magic book found. So some closing thoughts. Always follow the best practices, which Compose team recommends, and definitely question the usage of state and modifiers and how they're getting used. You want to try to scope them down as low as possible so that Compose knows that how much it needs to recompose and if it even needs to recompose or not. And then, yeah, like if you are in a similar situation like us, feel free to do multiple fixes. You don't need to fix all the jank in one go, right? And then the more the fixes, the more impact you'll have. And lastly, all the Compose phases which we showed matter a lot. So the less work you give to the compiler, the faster performance you're going to get. So just be aware of that. And yeah, all these phases matter a lot. And yeah, thank you so much. Here's the QR code. If you want to give some feedback to us, tell us how our slides were, or just help us improve more. And oh wait, there was one more thing.
Should we give them the book? We should link them to the book.
I wanted to, but the book just disappeared as soon as we showed it. I'm glad we have the slides now.
Yeah.
And the recording.
Wait,
do you have
I
the page?
think no, it just turned into this.
What's
after
that?
we finished all the. Oh my God.
That's amazing.
You know what? These books, they're tricky to work with. Well, thanks everyone.
Thank you.